Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. This video and the others in the Chapter 6 Problem Solving with Python playlist are an introduction to the concepts you will need to write programs with lists. This video accompanies Problem Solving with Python Chapter 6, but it's okay if you don't have the book. The videos stand alone as instruction on these topics. In the last video, we talked about how lists are stored in memory. If you haven't already watched that video, please watch it now, as it's helpful to understanding how lists can seem to be treated differently from other data types when passed as parameters to a function. In this video, we're going to talk about lists and functions, passing lists as parameters to functions, and returning lists from functions. Let's dive in. In this video, we'll return to our inventory example. This program is called inventoryfunctions.py. Let's run the program twice to demonstrate how it works. I can see it's printed a list consisting of 3 strings, talisman, or, and lime, and it asks me, what would you like to drop? I'll type or, just as it's written in the list, and press enter, and it says you've successfully dropped or, and it shows me the list consisting of talisman and lime. Now let me run it again, and at the prompt this time, I'll type something that isn't in the list, awful, and it says, you don't have awful, okay, and it again shows me the list, talisman or lime. Let's look at the code. This program has 3 functions: create inventory, which takes no parameters and returns a list; drop, which takes a string and a list of strings as parameters and returns a bool; and main, which takes no parameters and returns nothing. Main is where program execution begins. We have a call to main at the bottom of the script. Now in main, we've annotated inventory, a list of strings, item, a string, and dropped, a bool. The first executable line of code creates the inventory with the line inventory equals create inventory. That is our first function call or invocation. It then prints the inventory with a simple print statement, and then prompts the user for an item to drop. We then have our second function call, dropped equals drop item inventory. This function returns a Boolean result, which is assigned to a flag. We then test that flag with if dropped, and we print a message if the drop was successful, and a different message if the drop was unsuccessful. We then print the inventory again. And that's all. What's interesting about this program is the use of functions and how they interact with lists. Let's begin by looking at create inventory. Ultimately, I'd like to read the inventory from a save file, but for now, we're just hard coding some values. So this function takes no parameters, but what it's doing is still interesting. This function has a variable, new inventory, annotated of type list of string, and it defines that variable with the assignment statement new inventory equals the list of strings, talisman or lime. It then returns the list with the statement return new inventory. Back in main, this function is called with inventory equals create inventory. This will assign the memory address of the list created in create inventory to the variable inventory. I think it's worth drawing a picture of memory to illustrate how this function and returning a list from a function works. To understand this program, we need to understand both namespaces and the rules of scope, and how lists are allocated in memory and assigned. So I'm going to draw an image similar to the ones I was drawing in the memory video, but it's important we draw each function's frame or namespace separately on the stack because they are separate. To start, we have the module or main namespace and the heap. By main or module namespace, I'm referring to the global namespace, which is called the main namespace in Python. We have functions defined in that namespace, but no variables. We invoke the main function, so here I have a box to represent the namespace of the main function, labeled main. The names in this namespace are inventory, item, and dropped. They are part of the namespace, but not defined until they appear on the left side of an assignment statement, when they will be given a memory location of an object or value in the heap. Nothing references any value in the heap yet. The first executable line of code is inventory equals create inventory. Remember that assignment statements execute right to left, meaning we evaluate the expression to the right of the assignment operator, and then we assign the result to the variable on the left. You can think of this as the assignment operator having an extremely low precedence in order of operations. On the right, we are invoking the createInventory function. We'll put a frame on the call stack for createInventory's namespace, and that will include one variable, newInventory. The first executable line of createInventory is newInventory equals the list, talisman, ore, and lime. So we'll draw that list in the heap using the same abbreviated drawing style I used in the memory video. And the memory address of that list in the heap is stored in the variable newInventory. It's convenient to represent that as an arrow pointing from the stack to the heap, from newInventory to the list in memory. Now the final line of createInventory is return newInventory. This is returning the address or memory location of newInventory. And back in main, where the function is called, we're assigning what is returned to the variable inventory. So that memory location in our image, that arrow, is copied to the variable inventory in main. And once createInventory is done executing, its frame is removed from the call stack. Its namespace no longer exists. So a function can create a list and return the reference to it. And if we assign it to a variable where the function is called, then we'll be able to access and change that exact list. Now let's turn to the drop function, which takes a list parameter, but does not return a list. Still, it's clear from running the program that the drop function does modify the list inventory from main, because when we print the inventory after dropping an item in drop item, the item has been removed from the list in main. This might feel like lists are treated differently from ints, floats, and strings, because when we pass variables of those types to a function, changes to the variables in the function have no impact on the variables back in main. Lists are treated the same as other variables, though. In both cases, we're passing in a reference to the memory location of the variable. If we assign a new value to an int, float, or string variable, we're creating a new value in the heap and assigning that new memory address to the local variable. This has no impact on the local variable back in the calling function. It is the same with a list. If we assign a new list to a local variable, this will have no impact on the original list. Let's take a brief side trip and look at an example of this. This program is called changeparameters.py, and you can see that there are two functions, one called changeReferences and one called main. Execution begins with a call to main. Main assigns values to four variables, an integer 200, a string world, a float 3.14159, and a list consisting of 10, 20, and 30. It then prints those values and then passes them to the other function, changeReferences. In the function, each parameter variable is given a new value, 1, hello, 2.5, and the list 1, 2, 3, and then are printed. Then, back in main, we print the variables in main. Predict the output of this program. Now I will run it. And you will notice that the parameter variables were successfully changed to different values. But when we returned to main, these changes had no impact on the values in main. Let's draw a representation of this in memory. When the program begins, we have the global, or main as it's called in Python, namespace, and a heap that is empty of variables. We then invoke main, and so we'll draw a frame on the call stack for main with space for its four variables. The first line of code in main initializes number, so we'll draw 200 in the heap and an arrow from number on the call stack to 200. We then initialize word, decimal, and numbers, so I'll add those values in the heap and the arrows from the call stack variables to the values in the heap. Again, I'm abbreviating the way I draw a list. Now the program prints those, and then it invokes changeReferences, passing in those values. So I'll draw a frame on the call stack for changeReferences with all of its parameter variables, number, word, decimal, and numbers. And we copy the references from main to those parameter variables, so we copy the arrows over. Now both sets of variables, the variables local to main and the variables local to changeReferences, point to those values in the heap. But then we change each of those values. The first line of changeReferences assigns a new value, 1, to number. So we can draw 1 in the heap, and now the arrow from number in changeReferences points to that value, and no longer 200. It is the same for the 3 other variables. Let's focus on the list. The list 1, 2, 3 is a whole new list in the heap. So numbers in change references now points to that new list, which has no impact on the variable numbers back in main. When we print, we're now printing these new values in the heap. When we return, and we return without returning a value, the frame is erased off the call stack and we're back in main, where main still points to its original values in the heap, which are printed. Now this can inform our understanding of how inventory functions.py works. We were looking at drop. Before we do, we have to prompt the user in main for an item to drop. Let's imagine the user enters OR. So item in main will reference the string OR in the heap. We then invoke drop, passing in item and inventory. The drop function takes 2 parameters, item, a string, and from inventory, a list. When we invoke this function, we draw a frame on the call stack. As we noted in the change references example, the values from main are copied to these local parameter variables, which we can represent as the arrows being copied. There is also a local variable, success, initially assigned to the value true, which we will also depict as a value in the heap. Now there is the test, if item in inventory, and that will evaluate to true, so we'll execute the conditional code from inventory.remove item. Remember that many list functions operate on lists in place. This therefore removes item from inventory. This changes the list itself in the heap, and as we can see, this is the same list referenced by inventory back in main. We then return success, which is true. That arrow gets copied into dropped back in main, because we're assigning the result of the call to drop to the variable dropped. We then test if dropped is true, and print the successful drop message, and then we print the inventory again. It is now the changed inventory. If you want to be able to change a list in a function without changing the original list, the function should immediately make a copy of the list before making changes. If you want to pass a list to a function without changing the original list, you should pass a copy of that list to the function. Neither of these is what we want to do in this program, because the purpose of drop is to drop an item from the inventory that's passed in. I recommend that you practice drawing these images yourself and making predictions about how other programs that pass lists as parameters or return lists from functions will work. PythonTutor.com is an excellent resource for checking your predictions, as it will draw pictures that are a lot like these, at least for lists. That can further help you understand how parameters are passed and how lists are processed. Okay, that is a lot. I've included an auto-graded exercise in the description of this video that allows you to make choices about code that will change a parameter list and code that won't. Once you've mastered the concepts here, you're ready to move on.